today's video we will talk about something known as Titanic Dataset. We will understand what is this dataset all about, and today's video is gonna be really interesting. We will work with the seaborn module, and today we will complete our data preparation and data cleaning, and we will be ready. Our dataset will be ready to apply an AI model or AI algorithms. We can apply. We will make it ready to apply today. So let's start. By the end of this video, you will be able to completely clean a database and make it ready to apply an AI algorithm. Know how to use the apply function for applying any function on your database. Know heat map and count plot features of seaborn. Basically, it is about the seaborn module. Learn the different features of the Titanic dataset. So let us just start. So you see in my VS Code, I will suggest you to open your VS Code and download the Titanic dataset from kaggle.com. Kaggle.com. You go to kaggle.com and uh, you can just download your dataset from here, and you save it in a folder on desktop, and you go to that folder, right click and you then drop down menu will appear, select open with code, right? So this window will open up. Maybe you will be not having the other files, but this Titanic analysis, you can create a file with the extension IPYNB. I have told you how to create a Jupyter notebook. You can go, the link is in the description, and the how to download these heavy modules, NumPy, Pandas, PyPlot, Seaborn. You can easily download that. Also, the link is in description. You can go and check out that video. If you have already done, be ready with your editor, code editor, and let us just start. So first we import our libraries, all the libraries. Then we reference an object, pd.read_csv, titanic.csv. So here is our titanic.csv on the left pane. We can see the titanic.csv. We just need to write the word here. All, if you find some on the internet, if you find some database, just the link you need to copy paste here. And df equal to titan.copy. Why I am doing this? Because I may do a mistake while manipulating our data in the data frame. So we are just keeping the original copy safe and secure. So we, whatever alterations we will do on df. So let us see what is this database all about. So we can see passenger ID, survived, passenger class, name, sex, age, and SVSV means siblings, spouse, Parch means parents, children, ticket, fare, cabin, and embarked. So what is this about? It is about the Titanic, right? The tragedy of Titanic which occurred. You can see people were having few passenger ID. If they have survived, it is 1, and if they have not survived, it is 0. You need to analyze the data this way. When you are given a project, you need to work on, you need to analyze the data this way. What is P class? P class is the passenger class. If you see, it is either 1, 2, 3. What is name? Name of these people. And is the gender, age, how many siblings or spouse they were having, how many parents or children they were having on board, what is their ticket number, what is the fare they have paid, and in which cabin they have are, and where they have embarked. This is where they have embarked. They have embarked in, if there may be some islands or some shore. These are, so Q is Queenstown, S is Southampton, and C is Cherbourg. So what we need to predict? What do you think should be our X, and what do you think should be our Y? X may have multiple column, Y have single column, right? So Y is survived. Why I told Y is survived? Because suppose our AI model will predict what? But your AI model will predict name? Never, right? You can see the other things you cannot predict. Thing you can predict is Y. How you can predict? Where you have, if you know all the features, or if our machine learning models knows many features, there are many people, right? So if one feature is missing, and I know that name age and what they, in which cabin they were, and or like which passenger class they are, where they have embarked, we can say whether they have survived or not. So the remaining columns will be X and survived column will be Y. And seeing this, you need to drop few of the columns, and you need to convert everything to integer type or float type values. So what do you think? The name of a person, will it affect whether he has survived or not? Do you think the name of a person will affect whether he has survived in Titanic or not? Of course not. So for our analysis, for our data cleaning, for our AI model, this column of name is useless. Although for person it is very useful because it is their identity, but for us, for we people who are doing the analysis, this column of name is absolutely useless because it has no relation in knowing whether the person has survived or not. Whether a person is male or female, do you think it is necessary? Not at all. These also, right? Okay, so you can one thing you can argue with gender is that maybe someone has survived, maybe in a group of person, if trapped in a critical situation, some male were able to come out, or some female were given opportunity to go out and male stuck, or the vice versa may happen. So this you can argue little bit, so you can just keep it this column, but the name definitely doesn't affect, right? Age may affect, age can definitely affect, but number of siblings, spouse also, but they are integer values, right? So we don't need to bother about them much. What is the ticket number, what is the fare they have paid, these definitely don't matter whether they have survived or not, right? So we can easily drop name, ticket and fare, and we can also drop Kevin. There is a lot of null values, we need all the integer values. So let us see how to proceed. sb.heatmap.df.is null. This function you need to remember. It allows us to show how many null values we have in our database. You can see the black thing is 0. So we have to keep manipulating and do data cleaning until our heat map becomes pink in color. You can see what pink is 0.4, but we want 0, right? So why are you telling that we want pink in color? We want 0 as well as we want pink. So you will see that later, you will understand that later. As of now, you just need to know that you need to remove these null values. You cannot work with null values. Everything you need to be integer or float type in our machine learning model. So df.drop, we have to drop passenger ID, ticket, name, fare. These are not at all useful. What is the passenger ID? What is the name, ticket, fare? Not at all useful for our machine learning model to predict whether the person has survived or not. In place equals to true. If you don't give this, you will be in trouble because the original database will not be affected at all. This will create a separate copy of database. Suppose I do a equal to df dot drop this, and I don't give in place, then that a will drop these columns, but the original df will not be dropped. So axis equal to 1 means it is along the columns. Axis equal to 0 means it is along the rows. So these are column names. So axis equal to 1. In place equals to true means in the df actually the columns are gonna be dropped or deleted, in other words. So after dropping, we see our database looks something like this. So we are dropping cabin also, right? Because it has a lot of null values. What we will do with all the null values, right? We don't know anything, so what will our model do with something we don't know anything about? So we have dropped that also, and you see now the cabin is not there. Now you see df.heatmap, if you do, there were a lot of null values of the cabin. Now our data set has become little bit more cleaned than earlier. Now whether survived or I will give survived or answer, right? I am finding out the mean age. So why I am doing this? Because you see age, there are null values also. In age also there are null values. So what I am going to do is I will replace those who survived, I will replace their values with the average value of people who survived, average age of the people who survived, and answer being the average age of the people who died or not survived. I will replace the null values with respective positions. So we are going to see how to do that. So these are the values. These are not exactly the same. If you see the decimal places, fourth, fifth decimal places onwards. So df sb.count plot data equals to titan x equal to p class. So you can do one-on-one comparison of how many people, what is the count of passenger class 1, 2 and 3, what is the count of people. So you can see the maximum number of people were in passenger class 3. So you can analyze your data this way. What I am doing here is I need to convert everything to integer or float. So gender, I am doing pd dot get dummies. You need to understand this. This is similar to that one hot encoding I have told you. This is similar to that, not exactly, but it is very much similar. Pd dot get dummies. This is a short form, you can say. Titan of sex means the this Titan was the database, and we are getting the dummies of this in gender. Male and female, female is 0 and male is 1 means the person is male. Female is 1 and male is 0 means the person is female, right? So what we are going to do is we are going to drop one female column and keep only the male column, right? Or we can do the vice versa. We can drop the male column and keep the female one. Why? Because if one is male is 1, then of course female portion is 0 only, nothing else, right? And we can just from one column it is sufficient. We are not losing any data. Unless we are not losing any data, it is this is also a type of dimensionality reduction which we are doing. Embark equal to pd dot get dummies titan embark drop first equals to true. What we are doing is, you know, cqs, there are 3 places in which people embark. See here, c is hidden. So c is, I have deleted. Drop first equals to true means I have deleted c. Why we have deleted c? See, a person can embark at one place only, not more than one place. So if q is 1, then S and another column will be 0. If one is 1, the other two will be 0. If both are 0, then the other must be 1. So we are not losing any data if we drop the first column. So we will do drop first equals to true and only work with Q and S where they have embarked on. Then we do df equals to pd dot concat. We are concating our embark, gender, all these we are concating with axis equals to 1 means along the columns. Axis equals to 1 means along the columns we are doing our work. So this is the definition fill age. You need to, we are writing a definition function basically where age is something p of 0. What is p of 0? See, this, first you look at here. We are changing the age. We are changing the age column. That is, we are applying the we will replace all the null values with their mean of survived or not survived. So we are p is this. You see, p is this. Whatever function we will pass, apply function, it will go through all of these age values and apply, and we will this is the reference thing p, and it will apply the fill age function. What will our fill age function do? It will take p, which is this age and survived. Age is p of 0 and survived is p of 1. You can easily see that p of 0 and p of 1. If pd is null age, if age is null, then do something else, return age. If pd is null, then subcondition if survived equals to none, return sir, else return answer. So what was sir? It was the mean age of people who survived. Answer was the mean age of people who did not survive. So what our this definition function will do basically is replace all the survived null values with the mean of the people who survived, their age. So you can see there are no null values in the age now. Survived, p class, sex. You can drop this column now. You can easily drop this column because you have this data you are having in this form, zeros and ones. You can drop this column now. You can also drop this embark column easily now because q and s you are having. So you see now heat map, there is no null values, so there is pink. Now 0 is shifted to top middle position. So we have a pink. This pink color ensures the absence of any null values in the database. We need to have this pink color for our database to be completely cleaned. Otherwise our machine learning model will show error. Final database looks like this, right? We have dropped the gender, we have dropped embark. Our data, every data is numeric form, or all the data is in numeric form. We are almost ready to apply an AI algorithm after this data cleaning process. So yeah, that's all from this video. Meet